Good afternoon, my lovelies, and welcome back to Dr. Logic Awkwardly Does Logic. So we've got the worlds in our canonical model, maximal consistent sets, and now we need to define how they're related to each other. As I said, this is going to be much easier than all of the work we had to go through defining the world. In fact, I'm going to give you two definitions. We'll be done with it. We can move on. Well, not quite, because we are going to need to see what the consequences of the definitions are, but the two primary definitions are very straightforward, and we'll get them in this video, so we're basically all the way there. Think back to kind of generic Kripke models, possible worlds models, not necessarily canonical ones. They give us information about the possible worlds and how they are structured with respect to each other, and in a sense, the necessity falls out of accessibility. So if we want to know what things are necessary at W, we just have to look at all of the worlds accessible to W and find out what's true at them, and that will then determine the necessities at W. In the canonical model, we're kind of going to go the other direction. Instead of kind of looking to accessibility to determine necessity, we're going to look at necessity to determine accessibility. So given that each of our maximal consistent sets are made up of formulas, some of those formulas are going to be necessity formulas and some are not. And what we're going to do is we're going to look at this internal structure that the canonical models have, and then use that to determine which ones need to be related to each other. So with that, it's a little bit awkward in the abstract, but once I give you the definitions, it'll become a lot more clear. Let us get up our whiteboard and move over to the classic one, because I'm a classic kind of gal. So we have, as I said, one very easy definition. So let lambda be a set of modal widths. It is generally going to be a maximal consistent set, but the definition is much more universal than just canonical models, so we'll define this for any set of modal well-formed formulas. We will then define a new set, and unfortunately, it's got beautiful notation, but is really ugly to sort of read out loud. But we will call it the box minus of the set lambda, and this is defined to be the set of well-formed formulas phi such that box phi is in lambda. So if you'd like a slightly more set theoretic version of this definition, basically saying exactly the same thing, then the box minus of lambda is defined to be the set of phi such that box phi is in lambda. So if lambda is a maximal consistent set, then it will have a whole bunch of necessity formulas in it, a whole bunch of other formulas as well. But what we're going to do is we're going to look at all of the formulas with boxes, take all of the boxes off, and put the result into a set together. There you go. That's it. That's the key definition. Because from that, defining our accessibility relation is straightforward. So just remember our canonical models are defined with respect to a given set, given system S. So we've already defined our worlds. These are the maximal consistent sets. And so now we are in the position of defining the relation. And what we will say is that one maximal consistent set, gamma, is related to another maximal consistent set, delta, if and only if the box minus of gamma is a subset of delta. So the way to think about this is, so gamma is going to have, say, box phi, box psi, box delta, box gamma, and so on and so forth. So this means that the box minus of it is going to have things like phi and psi and gamma and delta and so forth. So if all of these guys are also members of delta, then we will say that these two sets are related to each other. So that means we'll have phi, and we'll have gamma, and we'll have psi, and we'll have delta, and so on. And what you can see is that I haven't kind of done it in the right order, but you can see that what we are doing by defining the accessibility relation in this way is setting things up so that the truth conditions work as we want them to do. So that if we have a necessity formula in some world, then that formula without the box is going to be in every world accessible from the first one. So that is the definition of the accessibility relation. Now, there's more to it than this. So we will want to see, it's like, okay, well, what does this mean for possibility? How do we do other interesting things? How are we sure that this is actually going to work the way that we want it to? But we'll save those results for the next video. You've got your two definitions. I hope you're feeling very happy, and I will see you again soon. Until then, take care. Cheers.